Hi, I'm Dave Ballo. I'm a VNA application engineer for Keysight Technologies. And what I'm showing here at IMS 24 is wideband active load pull. So what is load pull? Load pull means that we're measuring our amplifier here when it's driven into its nonlinear region, and we're providing different load impedances. So we typically care what's the output power, what's the distortion, what's the gain under these different load impedances. So the traditional way of doing load pull is with a mechanical tuner, but we're doing it here in an active sense. So what we're doing is sending a reverse signal into the amplifier that would be the equivalent wave that you would get from a mechanical tuner. So our setup uses a PNA-X. We're using the measurement receivers on the PNA-X, and our stimulus is coming from this vector signal generator on the bottom here of VXGC. The wideband part of the measurement is that instead of just doing CW signals, we are doing modulated carriers. So we're injecting a modulated carrier on the input, and then our synthesized reflection is also a modulated carrier. So we're using both channels of the VXG. Channel 1 is our input signal, channel 2 is the output, the reverse signal going to the output of the amplifier. So the results are shown here up on the display. The Smith chart is showing the different impedance points. And with active load pull, we can guarantee that these impedance points are constant over the full bandwidth of the signal. That's something that you cannot do with a traditional passive load pull system, where the impedance can only be controlled in the center of the band, and then there's a phase arc on either side of the center frequency. With active load pull, we can control it across the whole bandwidth. The other advantage of active load pull is that you could enter your own custom impedance profile. So for example, if this power amp were driving a phased array antenna system, the impedance that this amplifier would see would vary as a function of beam angle. So now you could import that S1P file that corresponds to your antenna pattern and do all this analysis now with a real-world impedance profile. What the display is showing are the things that you care about to look at under the different load conditions. Here is the output power of the amplifier, here is the gain, and here is the in-band distortion. And each of these curves corresponds to one of the different impedance points where we made the measurement. So if you're a power amp designer and you want to do these kinds of characterization of your device under real-world conditions, come to Keysight. We support active load pull, we support passive load pull. You can find more information on our website, keysight.com. For this setup, just search on wideband active load pull and you'll bring up more information about this application. Thanks for watching.